All right, in section 4.1, we're talking about linear functions. Okay, so a linear function is a function whose graph is just a straight line. Linear functions can be written in the slope-intercept form of a line, which is, we know it to be not f of x, but y equals mx plus b. But remember, y is can be written as f of x. It's just a really fancy way of writing y. Okay, we know that b is the initial or starting value of the function, or we know it as the y-intercept. And we know that m is the rate of change or the slope of the function. And the y-intercept can be put into an order pair as 0 and then b, whatever this number is. Okay. So let's look at this right here. Determine if the table represents a linear function. So we're going to look at the increase in x values and the increase in y values and see if it's a constant increase. So if we go from 3 to 9, so that would be plus 6. From 9 to, so we'll put plus 6. From 9 to 15, that's plus 6. From 15 to 21, that is plus 6, so that's constant. And then let's look at between 7 and 18, that would be 11. From 18 to 29, that would be plus 11. And then from 29 to 40, that would also be plus 11. So we've got constant change in the x values and the y values, so that would represent a linear function. So linear function. Okay, let's look at this table. Alright, we go from 7 to 14. That is an increase of 7. From 14 to 28, that is an increase of 7. From 28 to 35, that is an increase of 7. Now let's look at the y values. From 90 to 99, that's an increase of 9. I'm sorry, going from 14 to 28, that's not just an increase of 7, that's an increase of 14 there. Sorry about that. Okay, going from 99 to 117, well, that's not an increase of just 9 right there. That's an increase of 18. And then you go from 117 to 126. Now that is an increase of 9. Okay, now notice right here at this increase of 14, that's the same thing as 2 of the 7s, 2 times 7. Now notice here, this increase of 18, that's an increase of basically 2 times 9. So it's like we skipped 1 point and we added 7 twice to the 14, we added 9 twice to this 99. So this is still a linear function. It's still going at a constant rate. Okay, now let's look at this one. So from 4 to 7, that's an increase of 3. From 7 to 10, hey, that's an increase of 3. From 10 to 13, that's also an increase of 3. Now from 17 to 19, that's an increase of 2. From 19 to 25, that's an increase of 6. And then from 25 to 40, that's an increase of 15. Okay, so notice over here in the x values, those are constantly increasing by 3. But over here with the y values, it's not a constant increase. So this would not be a linear function. So not a linear function. Okay, now let's look at increasing, decreasing, and constant functions. So an increasing function, like we see right here, this would have a positive slope. A decreasing function, like we see right here, would have a negative slope. A constant function, like we see right here, which is basically a horizontal line, that would have a 0 slope. and it talks about this right here, the slopes of increasing, decreasing, and constant functions. So if we have an increasing function, then the slope is going to be greater than 0, which is saying that it's positive. If we have a decreasing function, then the slope is going to be less than 0, which is saying it's negative. And if we have a constant function, then the slope is going to be equal to 0, just like I said over here, okay, with each one of these. Okay, now let's look at this right here. Is y equals negative 34x minus 5 increasing, decreasing, or constant? Well, let's look at the slope. And notice how this is already in y equals mx plus b format. So we can look at the number right in front of x, and that will give us our slope. Okay, so the number right in front of x is a negative 34. So since m is equal to negative 34, and since it's a negative number, we know that this function is decreasing. Okay, so for this one, is y equals 6 over 5x minus 2 increasing, decreasing, or constant? Same thing, this is already in mx plus b format. If it wasn't, we would first need to put it into y equals mx plus b format, and then we can look at the slope. So the number right in front of x, which is a positive 6 over 5. So since it's positive, we know that it is an increasing function. Now let's look at this. Y is equal to a negative 9. Is it increasing, decreasing, or constant? Well, we can write this as in mx plus b format. We can write it as 0 times x minus 9, because this entire term here would go to 0, and you're left with y equals negative 9. Okay, so what we're saying here is m is equal to 0, so that means that we have a constant. And you don't have to go through that. You can just see that y is equal to just some number, and the number is a constant, so you know that the function or the graph of this function is going to be constant. Now be careful when you have something like this, x is equal to negative 9. That is not actually a function, because when you graph this, and we'll get to this a little bit later, when you graph this, here's negative 9, you would have a vertical line. And remember, the vertical line test is to test whether a function is a function. Well, since this is a vertical line test, and it crosses the point here, 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 it fails the vertical line test, so it's therefore not a function. So we can't say, well, is it an increasing, decreasing, or constant function? Because it's not a function at all to even begin with. Okay, so just be careful when x is equal to something. That's not even a function. Okay, so determine if the graph is increasing, decreasing, or constant. Notice how you read these from left to right. So notice how this is going in a downward direction. So this is decreasing. You can also find the slope of this, and you would find it to be negative. Here, read from left to right. Notice this is going in a upward direction. So this is an increasing function. And notice how this is a horizontal line. So since it's a horizontal line, we know it is a constant function. It never changes. Okay, now let's talk about the slope of a line, which we know it represents m. It represents the change in y over the change in x. So we have 2 points, and we can name them x sub 1, y sub 1, and the other one x sub 2, y sub 2. And we can use those points to determine the slope of the line. So slope is rise over run, or you can say y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now in the equation y equals mx plus b, we know m is the slope and b is the y-intercept. So you could rewrite this as y is equal to slope times x plus the y-intercept. Now it doesn't matter which point is labeled as y sub 1, y sub 2, or sorry, x sub 1, y sub 1, or x sub 2, y sub 2. You can interchange those and it won't change the value of the slope. Okay, now types of slope, we've already kind of gone over this. This would be a positive slope because we have an increasing function. This would be a negative slope. We have a decreasing function. This would be a zero slope. It's a constant function. This is an undefined slope. It's not even a function. Okay, so this right here would be y is equal to 2, whereas this would be x is equal to 2. Okay. So let's find the slope of a line that passes through these 2 points. Now I could say that this is x sub 1, y sub 1, and this is x sub 2, y sub 2. Or I could switch it. I could say that this is x sub 2, y sub 2, this is x sub 1, y sub 1, and it's not going to change the value of my slope. Okay, so if we just keep it like that, so m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, so we've got y sub 2 is 6, and then minus, y sub 1 is 4, x sub 2 is a negative 2, minus, and x sub 1 is 1. So 6 minus 4 is 2, negative 2 minus 1 is negative 3. So this is negative 2 over 3. And there's your slope for a line that passes through those 2 points. Alright, now we're going to have a graph, and then we're going to try to find the slope of the line based on this graph. Now what I'm going to try to do is I'm going to try to find easy points on this graph. So looks like we've got a nice point right here. That looks like that is negative 4, 4. And then another nice point looks like right here. Looks like that is 4, negative 2. Okay, so we have negative 4, 4 for this one, and 4, negative 2 for this one. Okay, so we can say that this is x sub 1, y sub 1. We'll call this x sub 2, y sub 2. So m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Y sub 2 we said was negative 2, okay, minus. Y sub 1 is 4. Over x sub 2 is 4 minus x sub 1 is negative 4. I'm going to put those in parentheses. So negative 6 over, this is 4 plus 4. So negative 6 over 8. Now it looks like I can take add 2 out of both of those, and I'm left with 3 over 4. Now, should this be a negative slope? Well, looking at our graph, it is decreasing, so yes, it should be a negative slope. Okay, now we're going to identify the slope and the y-intercept of the equation y equals 4x plus 12. Now notice the first thing we need to check is it in the mx plus b format? Which yes it is. So this one should be easier to look at. Our slope should be 4 and our y-intercept is 12. Now we're going to put that in an ordered pair. That would be 0, 12 for our y-intercept. Now looking at this one, it is not already in y equals mx plus b format. So what we need to do is take this and solve for y first. So I'm going to move that 9x over. Then I'm going to divide each term by 3. So y is equal to 3x plus 2. So from here, we know that the slope is 3 and the y-intercept is 2. If we write that as an ordered pair, that would be 0, 2. Now let's look at something called the point-slope formula. So if you're given a point and a slope, the point-slope formula will lead to an equation of a line. So that is y minus y sub 1 is equal to m times x minus x sub 1. Now you will enter values for this term here, here,